A good strategy to solve logarithmic equations is to put the problem into exponential form instead. We did this a little bit when we were solving more straightforward logarithmic equations, but it works for more complicated ones as well. To change this problem into exponential form, what I'm going to do is identify the base of the log. This is log base 4. And then that exponent acting on the 4 is going to be the 3, what this equals. So this becomes 4 to the third power equals 8x minus 6. 4 to the third power is 64. And now we just solve this equation. Add 6 on both sides. 70 equals 8x. Divide both sides by 8, and we get 70 divided by 8. We can simplify that fraction, or just write it as a decimal. 8.75 equals x. Solve the natural log of 3x plus 2 equals negative 1. And I see we need an exact answer and an approximate answer. Consider what is the base of natural log. It's log base e. In exponential form, this equation becomes e to the negative 1 power equals 3x plus 2. E to the negative 1 is not a very pretty number if I were to write it in decimal form, but it's still a number. I can write it as 1 over e equals 3x plus 2. Since I know that I'm looking for an exact answer, I want to leave that as 1 over e. I don't want to enter a decimal. I'm going to subtract 2 on both sides. 1 over e minus 2 equals 3x. And then I'm going to divide both sides by 3. But I notice that when I try and divide by 3, I don't really want to divide this side by 3 because I'll have a complex fraction. So instead, I'm going to multiply by 1/3. This becomes 1 over 3e minus 2/3 equals x. That, as ugly as it is the exact answer. For the approximate answer, I'm going to enter into my calculator 1 divided by 3 times e. You should have a button that just says e on your calculator. If you don't, look for the e with the caret symbol and just raise it to a power of 1. That's the same thing as just e. 1 over 3e minus 2 over 3 equals approximately negative 0.54404, goes on from there. Let's round it to 4 decimal places, which means our answer is negative 0.5440. Thank you.